Good evening all my dear, I am Rakesh Chauve from Sunbeam Sun City. Jai Hindi all my dear. Now my dear, in the topic after the real depth, apparent depth and refractive index, there is a topic, there is one question. And the question, there are two questions I have written on the board, you can see. And the questions are related to the concept of refraction. Now what is the question? The question is, how refraction affects, I said, how the phenomena of refraction affects the length of the day. My dear, due to refraction, you must be knowing from class 10 there was one question. Due to the phenomena of atmospheric refraction, the sun appears to be rise 2 minutes early and it appears to set 2 minutes late. Please, you must be knowing this question. That rising of the sun is 2 minutes it's 2 minutes early from its actual time, and the setting, similarly the sun sets 2 minutes later than the actual time. So my dear, this concept which is given in your class 10th, let us discuss that how this is happening. The same question can be called this way, that there is a apparent shift. It's not real shift. There is an apparent shift in the position of the sun at sunrise and sunset. Not only sunrise there is an apparent shift, there is an apparent shift during sunset also. And then it is said, that is, if there is an apparent shift in the position of the sun at sunrise, so that apparent shift is caused 2 minutes early in sunrise and the apparent shift in sunset 2 minutes later. And because of that, my dear, 2 minutes early, 2 minutes later, that is total, it is 4 minutes. Then the question becomes, that is increase in the length of the day by about 4 minutes. About 4 minutes, my dear, you can see. And this is due to the refraction. So how this is happening, we will discuss with this diagram. I have drawn this diagram in front of you. So my dear, here, look at the diagram. But before that, there is one concept. And I am writing the concept here. Please try to understand the concept. Now my dear, you must be knowing, as we go, this is say Earth. And this is the atmosphere. Right? Surrounding the Earth. So my dear, as we go up from the Earth's surface, as we go up, right, in the space that is crossing the atmosphere, we are going up. Now my dear, in this case, the refractive index will go on decreasing. Why refractive index is go on decreasing, my dear? Because you all know that sir, refractive index jitna zyada hota hai, right? The refractive index is more, it means medium is more and more denser. And if refractive index is less, the medium is more and more, or it becoming rarer. I repeat, when Ri is more, the medium is denser. And when Ri is less, then we can say the medium is rare medium, right? So now my dear, as we go up, actually density decreases. I said D for density decreases, right? And since the density decreases, my dear, the refractive index of the medium also decreases. You all know, because I said, jitna kam Ri, उतना कम डेंसिटी. सो अगर डेंसिटी डिक्रीज हो रहा है, सो Ri will also decrease. It means we are going from denser medium to rarer medium, because when we near the Earth, the medium is more dense. And as we go above and above from the Earth, the medium become rarer and rarer. You can take this in the point. Sir, finally when we reach to space, that is called empty space, which is nothing but vacuum. So, जब हम Earth के near में रहते हैं, तो medium is denser. But as we move above, we are reaching in a space, and space is called vacuum, and you know Ri of vacuum is less than Ri of any denser medium. So you can imagine from this concept, sir, as we move up from the Earth's surface, sir, the density and refractive index decreases. Am I clear? That is, in other way around, you can say you are moving from denser medium to rarer medium. Now look at the reverse case, and when you are coming down, I am drawing here. Here is the Earth, and here is the atmosphere. And here is space. So here this is my figure 1. Now here is space in figure 2. Now when you are moving down, that is from space towards the Earth. When you are moving down from space towards the Earth, what will happen? Density will increases, Ri will increases, and we are moving from rarer medium to denser medium. We are moving from rarer medium to denser medium. So I have given you two concepts. When we are moving from Earth to the space, that is to top, the density goes on decreasing, Ri goes on decreasing, and we say we move from denser medium to rarer medium. And when we are coming down, that is from ulta process, that is from space to Earth, that is from top to bottom, that is towards Earth, then what will happen? Sir, we are coming from rarer medium because we are coming from space. Space is more vacuum, right? So it is more lighter. So that is, we are coming from rarer medium and entering in the denser medium as we are reaching to the Earth atmosphere. So we are coming from rarer to denser, and when we are coming from rarer to denser, you can imagine rarer to denser, matlab mu value will go on increasing because you are entering in a denser medium. So mu will go on increasing, and if mu increases, you know density also increases, my dear. Okay, so this is the two concepts I have given, concept number 1 and concept number 2. So from figure you can see here I am writing figure 2. So now let's start this topic to explain that what is happening here in this topic, how this is causing the increasing in the length of the day by about 4 minutes. So now my dear, now it is as what I said here, this two diagram you can see, right? So now here the sun, it is in the space, right? It is beyond the atmosphere at altitude from the Earth and a height pair. So look at the second diagram for this. Here is the sun, and the light from the sun, the light ray from the sun reaching to the Earth, to the observer, that is, it is going like this. It is going like this. This is the light ray reaching from sun S to the observer on the Earth. Now simple question to you all. The sun is in space, you can see here, and it is going to the Earth. Matlab, the light ray from the sun is traveling from rarer medium to denser medium. Because I told you in my figure number 2 that as soon as we are coming from space to the Earth atmosphere, towards Earth, that the density goes on increasing. Ri is go on increasing. That is, we are going from rarer medium to denser medium. So when the light ray is started from the sun, that is, say the position of the sun is at S, it will become from rarer medium to denser medium. Hence, what will happen, my dear? Hence, it will bend. Who will bend? The light ray band. Hence, light rays. Hence, light rays bends towards normal. This is the first point, my dear, that the light ray from the sun is traveling from rarer medium to denser medium. I repeat, the light ray from the sun will travel from rarer medium to denser medium. Hence, the light ray bends towards normal. You can see it bending towards normal. Towards normal, you can see. So simple concept. So it is bending towards the normal. Say horizon is, take them for observer, this is the normal, you can see. And the light is bending towards the normal because the light travels from space to earth atmosphere, that is from rarer medium to denser medium, but natural it is bent towards the normal. Now point number 2, my dear, which you can see, but the observer which is on the earth, how it will be observe this light rays? The observer sees this object as a sun, because for observer the sun acts as an object, right? So the observer sees an object in the direction of ray of light. Now in the direction of ray of light, अब ऐसे घूम के तो नहीं देखेगा observer, ऐसे इतना घूम के तो नहीं जाएगा. So what is the direction of the ray of light? So direction of the ray of light can be drawn by drawing a tangent to this. So if I draw the tangent to this, like this, I am drawing the tangent. So look at what will happen. Here is the tangent drawn. Here is the tangent drawn. My dear, this is called direction of a ray. Direction of a ray. And now what will happen? I am getting the sun apparently at this position. I am getting the sun apparently at this position, my dear. Because this is a concept that observer sees an object. Here is an observer. He sees an object in the direction of ray. How will get the direction of ray? How will get direction of ray? Sir, I will draw the tangent to this. See, I am drawing the tangent to this. So as soon as I draw the tangent, I got the direction of rays. So when observers look the object, it will be see the object in the direction of ray. And because of that, direction of ray के वजह से reaching in heights. So because of that, the sun which is actually below the horizon, the sun which is actually below horizon appears. The sun which is actually below horizon, you can see, is appeared where, my dear? Is appeared in the position S dash. You can see here I have write the position S dash. So which is actually below horizon appears in the position S dash above horizon. That is, there is apparent shift. There is apparent shift in the position of sun by nearly 0.5 degree. So my dear, here you can see this angle I am drawing here, it is somewhere 0.5 degree. Say sun shift हो गया, apparently shift हो गया. So my dear, this is what is the concept. The sun by nearly 0.5 degree, that is, my dear, you all know that. Here I am writing one more line. 1 degree is equal to 6 minutes. Sorry, 1 degree is your nearly, when we are talk about 0.5 degree, you all must be knowing that when you talk the 0.1 degree is near about, there is a situation that when we say 0.5 degree, this is nearly, that is 2 minutes. That is 2 minutes difference it will cause. And that 2 minutes difference is, so that is 2 minutes early, sun rises or sunrise, and hence it will set 2 minutes, and hence it will set 2 minutes later. So I hope, my dear, you can understand this 2 minutes early and 2 minutes later caused to increase the length of the day by about 4 minutes. So my dear, this is the actual reason of shifting of the sun during sunrise and sunset. Or you can say increasing the length of the day by 4 minutes. Sunrise is appear early by 2 minutes and sets later by 2 minutes. So total it will be 4 minutes. So my dear, this is the answer. So let me tell you one thing once again, which is very important to conceptually, that you should aware about it, that what is actually happening here, that I have started with figure 1. I said there is a earth, there is an atmosphere around the earth, and sun, there is in space. So when we go from earth to space, that is we are going from, my dear, a denser medium to rarer medium. So what will happen? The mu will goes on decreasing, density also goes on decreasing. But when you are coming from space to sun, space to earth, that is from sun to earth, you are coming from rarer medium to denser medium. The light coming from rarer to denser. And that is the reason why, my dear, the Ri and density will increase. Okay. Now, my dear, in this case, the sun, the light from the sun reaching to the observer on the earth, so it is traveling from rarer to denser. So it will bend towards the normal. Am I clear? Okay. Yeah, that's okay. Now it is bending towards the normal, you can see. But the question is, sir, when observer see the object, he see the object in a direction of ray of light. I have written this. Observer will see the object in what direction? In a direction of ray of light. And direction of ray of light is drawn by straight line. Because ray is what? A light in a straight line. So direction of ray of light will be drawn by drawing a tangent. So जैसे मैंने ये curve पे I have drawn the tangent, I observe that the sun shifted apparently. As soon as I draw this, because the observer will see the object in the direction of the ray of light. The direction of the ray of light is a straight line. ऐसा curve नहीं होगा. So what should I do? I should draw the tangent to this. So as soon as I draw the tangent, I observe that sun is apparently, you can see, the sun is apparently shifted the position. And that's my dear, a question. So when sun apparently shifted the position, so what is the shift in the position? Earlier it was below horizon, but now sun shifted apparently and it is observed above horizon. So I written this. The sun, which is actually below horizon, appears in the position S dash above horizon. There is an apparent shift in the position of the sun by nearly 0.5 degree. And this 0.5 degree, my dear, is, so this 0.5 degree, that is 0.5 degree means that is 2 minutes. It caused a difference in sunrise and sunset, that is 2 minutes early there is a sunrise appears and hence it will set the 2 minutes later. So in all, my dear, there will be 4 minutes difference it causes. So my dear, this is the entire answer. You can write this as a point number 2, that here the light from the sun is traveling from rarer to denser, hence light will band towards the normal. Point number 3, you can write for this answer that the observer sees an object, because whenever the observer sees an object, he will see the object in the direction of the ray of light. And direction of the ray of light, sir, because there can be a doubt of yours, sir, light is going like this. So the observer ka observe yahi hoga. No, my dear, it is a curve. I said he see an object in the direction of ray of light, and direction of ray of light is a straight line. It is a ray of light. So how to get that straight line? To draw the tangent. As soon as I draw the tangent at this point, you can see. Now my dear, as soon as I draw the tangent to this, I observe that the sun shifted its position apparently. Am I clear? And I observe the sun here instead of here. So this is what is the reason, and very important, the first point for any of these two questions, the very important answer is this is due to this, both the question is due to, this is due to atmospheric refraction. Atmospheric refraction. So remember this, my dear, whenever you have to ask this question, you should write in short, no issues. I have tried my level best to explain, and therefore it is going lengthy of this 20 minutes video. But my dear, in the exam you write two very important lines. One, sir, these two questions, either apparent shifting of the sun or either flattening of the sun at the sunset and sunrise is due to atmospheric refraction. This is one common line between these two answers. And second, in the first question, the light from sun is reaching to earth from rarer medium to denser medium, and hence it will bend towards the normal. And when it will bending towards the normal, as soon as I draw this figure, I observe that the observer will see the object in the direction of ray of light. This is also very important to understand why it is a straight line. So when observer see the object, he see the object in the direction of ray of light. So I need to draw the tangent to this curve. As soon as I draw the tangent, because observer required to see the object in the direction of ray. So as soon as I draw the tangent to this curve, so that it become a direction of a ray, I will observe that sun shifted apparently its position from below horizon to above horizon. And there is a shift in the degree of nearly, there is an apparent shift in the position of the sun by 0.5 degree. And that 0.5 degree means during sunrise, it appears 2 minutes early the sunrise will take place, actual sunrising say, and it, hence my dear, it will set 2 minutes later than actual sunset say. So this is what is causing to increase the length of the day by about 4 minutes. So I will stop here. Similarly, the second answer is also due to the same reason, my dear. In the second question, the sun horizon appears flattened at sunset and sunrise. Again, your answer is common. This is due to atmospheric refraction. At least 1 mark though you should deserve by writing this answer. This is due to atmospheric refraction. Why I am saying this question was asked in the exam, board exam, CBSE class 12th examination already. So you should aware this small answer at least. This is what is both the concepts, even the apparent shifting of sun, even the flattening of the sun during sunset and sunrise is due to atmospheric refraction. My dear, in the second answer, this is due to atmospheric refraction, and in this case, we will go opposite. Look at my figure number 1. As soon as we go from denser medium to rarer medium, that is now we will go from earth to the sun. In the first question, we are coming from sun to earth. Why? Because the question is apparent shift in the position of the sun. मतलब यहाँ पे जो भी हो रहा है, whatever is happening with the sun. So I have started from sun to earth, but in the second question, the sun near horizon appears flattened at sunset and sunrise. No doubt it is due to atmospheric refraction. But this answer you will write this way, that as soon as we go from denser medium to rarer medium, you can see the refractive index goes on decreasing. the density goes on decreasing, and my dear, if refractive index goes on decreasing, the refracting angle, because mu is equal to sin I by sin r, so as the mu changes, the refracting angle also changes, and hence due to that the sun will be flattened during sunrise and sunset. So more or less both the answers is commonly same with the same reason, and the reason is atmospheric refraction. So that's all from my side for this question. Now after this I will go for total internal reflection. Thank you, Vachcha.